Find f prime at a when ft is this fraction, this quotient 10t plus 1 over t plus 8. This is a rather detailed question. So to find the derivative, we always employ limit h approaching 0, f of a plus h minus fa the whole over h. So notice f of a plus h. What is f of a plus h? Wherever you see t, I'm going to plug in a plus h. All right. 10 a plus h in parenthesis plus 1 by a plus h plus 8. That's this one minus f of a. Wherever I see t, I replace it by a. All right. So that's the second one, the whole over h. Now, this is a fraction, this is a fraction. You need common denominator. Common denominator is this factor times this factor. All right. So what's missing here? I need to multiply this by a plus 8. So I do so upstairs and downstairs. Notice I have distributed the 10 and that's how you see it here, right? Likewise, here I need to multiply by a plus h plus 8, numerator, denominator. Next step, carefully distribute, right? Multiply. You know how to multiply. When you carefully multiply, subtract. Remember, all of this goes in parentheses and therefore it is going to change sign throughout. All right. So remember to distribute that negative. Okay. After that, you notice things start getting cancelled. Okay. This h denominator is to be thought of as h over 1. So fraction over fraction is nothing but numerator times reciprocal of the denominator. All right, cancel things out. Notice only the h quantities survive. So 80h minus h gives me 79h. Well, that's good. That h cancels this h. So all I have is 79 over all of this. I'm letting h go to 0. Okay. And that goes to 0. So I get 79 over a plus 8 quantity squared. Okay. 79 over a plus 8 quantity squared. Next. Find the derivative when fx is square root 6x plus 7. Well, again, the same definition. Derivative is the limit h approaching 0, f of a plus h minus fa over h. My function fx is square root 6x plus 7. So I'm going to substitute a plus h where I see x. Okay. So don't forget to distribute, right? Well, I'm not yet distributing, but we'll see that in a minute. But anyhow, don't forget to put it in parentheses. Once you see that, anytime you have such a radical expression, try conjugation. So you're multiplying by the conjugate of that factor, numerator and denominator. What's the purpose of conjugation? Well, it will square each term in your first factor. Square minus square. So that is difference of squares formula. A minus b, a plus b, a squared minus b squared. All right, so that's perfect. Square cancels the square root. I have this quantity minus square cancels the square root. I have the second quantity in parentheses. Why in parentheses? Because of that negative, because of that subtraction. Okay. You open it out. You open this out. Things cancel. Only the h term survives. And remember, there was an h downstairs. They cancel. Now when you let limit approach h approach 0, it's only that h goes to 0. So you have 6 upstairs and 6a plus 7 square root plus square root 6a plus 7. So twice square root 6a plus 7. The 2 reduces the 6 and this is your solution, right? So how do you write it in web work? I have 3 above over square root is sqrt parenthesis 6a plus 7. All right. Next problem. Now here is you are given a limit. You are asked to find f and a. Okay. One thing to notice, compare your expression to one of these because these are the two definitions you have. Since h is approaching 0, I will use this expression instead of this. Okay. H is approaching 0. F of a plus h. That tells me a is 1 and the function is power 10. For a plus h, I have a plus h power 10. So that is a is 1 and fx is x power, right parenthesis, 10. Okay, don't forget parenthesis, otherwise it only takes exponent 1. All right. Next question. Same situation. You have an expression here. What is the f? What is the a? Look, x is approaching 5, so I'm going to use the second option. X is approaching a, so that tells me a is 5. Once I know what is a, what is this? 2 to the x, that is my fx. 2 to the x. Make sure 2 to the 5 is indeed 32, so that's correct. All right, the next one. Limit x approaching pi by 4. Tan x minus 1 over x minus pi by 4. So that again applies to the second definition. X approaching a. So a is pi over 4. Okay. What about the function? Function looks like tan x. Check. Is tan of pi by 4 1? It is. So function is indeed tan of x. Next. T approaching 1. So it's not going to be this, it's going to be this. So a is 1. All right. It's t here, but x. Well, what's in a name? Variable is variable, right? So what should be my fx? Fx minus fa, so minus, right? So fx should be this, except it should be in x. So x to the power 4 plus x. Check. When you plug in a equals 1, x equals 1, what do I get? 1 plus 1, 2. So that is f of a. So that's fine. All right. This is a longish question. I'll come back to it in our next video. Until then.